As per the National Electrical Code, a neutral conductor can carry the unbalanced current of all the phase conductors that it serves. However, this capacity is limited to 200 amps. The applicable code reference is National Electrical Code Section 310.6. A3, which states that the neutral conductor shall have sufficient ampacity to carry the unbalanced current from other conductors. The rule of thumb does not explicitly limit the sharing of neutrals to 15 or 20 amp breakers. However, the 200 amp limit on neutral capacity implies that neutrals should generally not be shared for larger breakers. For 15 and 20 amp breakers, it is common to share multiple breakers on a single neutral conductor. For 30 amp breakers, it is typically recommended to dedicate a separate neutral conductor for each breaker. For larger breakers 40 amps or more, it is always advisable to use dedicated neutral conductors. There are some additional considerations to keep in mind. Firstly, the neutral conductor should be of equal or larger size than the phase conductors it serves. Secondly, the neutral conductor should be insulated and color-coded white or gray. Thirdly, the neutral conductor should be connected to the neutral bus in the panel board. Fourthly, the neutral conductor should not be used as a current-carrying conductor for the system. The key is to understand the principles behind neutral sharing and the code requirements that govern it. This will help to ensure a safe and compliant electrical installation. Now let's delve deeper into the nuances of neutral conductors and their proper application in electrical systems. Firstly, we will explore the concept of unbalanced current and how it relates to neutral sizing. Secondly, we will review the National Electrical Code requirements for neutral conductors in multi-wire branch circuits. Thirdly, we will discuss the practical considerations for sharing neutrals in different types of electrical systems. The neutral conductor in an electrical system serves as the return path for current from the load back to the source. In a balanced three-phase system, the currents in the three phases are equal and 120 degrees apart. Therefore, the neutral current is ideally zero. However, in reality, electrical loads are rarely perfectly balanced. This imbalance results in a neutral current that must be safely carried by the neutral conductor. The amount of unbalanced current depends on the type and distribution of the loads. For example, a lighting circuit with a mix of incandescent and LED lamps will have a different unbalanced current than a circuit powering a motor. The National Electrical Code requires that the neutral conductor have sufficient ampacity to carry the maximum unbalanced current that it is likely to encounter. This is typically calculated based on the connected load and the expected load factor. For example, for a multi-wire branch circuit serving receptacle outlets, the National Electrical Code allows the neutral conductor to be sized based on the assumption that the maximum unbalanced current will not exceed the rating of the branch circuit to overcurrent device. This is because receptacle outlets are typically used for a variety of loads, and it is unlikely that all of them will be operating at their maximum capacity simultaneously. However, for circuits serving specific loads, such as motors or heating elements, the neutral conductor must be sized to carry the full unbalanced current. This is because these loads are more likely to operate at their maximum capacity for extended periods of time. In addition to the ampacity requirements, the National Electrical Code also specifies other requirements for neutral conductors. These include requirements for insulation, color coding, and termination. Neutral conductors must be insulated to prevent accidental contact with other conductors or grounded surfaces. They must also be color-coded white or gray to distinguish them from phase conductors. Neutral conductors must be properly terminated at the neutral bus in the panel board. This ensures a solid electrical connection and prevents overheating. The National Electrical Code also addresses the use of neutral conductors in multi-wire branch circuits. A multi-wire branch circuit is a circuit that consists of two or more ungrounded conductors and a common neutral conductor. Multi-wire branch circuits are commonly used to supply power to receptacle outlets in residential and commercial buildings. The National Electrical Code allows the use of multi-wire branch circuits under certain conditions. One condition is that the neutral conductor must be sized to carry the maximum unbalanced current that it is likely to encounter. Another condition is that the overcurrent device protecting the circuit must open all ungrounded conductors simultaneously. This is to prevent the neutral conductor from being overloaded in the event of a fault on one of the ungrounded conductors. In addition to the National Electrical Code requirements, there are also practical considerations for sharing neutrals in electrical systems. One consideration is the type of loads that are being served. It is generally not recommended to share neutrals between circuits serving different types of loads, such as lighting and motors. This is because different types of loads can have different harmonic content, which can cause the neutral conductor to be overloaded. Another consideration is the distance between the panel board and the loads. The longer the distance, the greater the voltage drop in the neutral conductor. This can cause problems with the operation of the loads, especially if they are sensitive to voltage variations. Finally, it is important to consider the potential for future expansion when designing an electrical system. If it is likely that additional loads will be added in the future, it is best to install dedicated neutral conductors for each circuit. This will prevent the need to upgrade the neutral conductors later on. In summary, sharing neutrals in electrical systems is a complex topic with many factors to consider. The National Electrical Code provides specific requirements for neutral conductors, but it is also important to consider the practical aspects of sharing neutrals in different types of electrical systems. By following the National Electrical Code requirements and taking into account the practical considerations, it is possible to design a safe and reliable electrical system that utilizes shared neutrals. Let's discuss the sizing of the neutral conductor in more detail. The National Electrical Code provides specific guidelines for determining the minimum size of the neutral conductor. These guidelines take into account the type of loads being served, the length of the circuit, and the allowable voltage drop. For example, for a residential dwelling unit, the National Electrical Code allows the neutral conductor to be sized based on the square footage of the dwelling unit. This is because the load in a residential dwelling unit is typically distributed relatively evenly throughout the dwelling unit. However, for a commercial building, the National Electrical Code requires the neutral conductor to be sized based on the actual connected load. This is because the load in a commercial building can be concentrated in certain areas, such as office spaces or retail areas. In addition to the National Electrical Code requirements, it is also important to consider the recommendations of the equipment manufacturers. Some equipment manufacturers may recommend that the neutral conductor be sized larger than the minimum size specified in the National Electrical Code. This is to ensure that the equipment operates properly and to prevent overheating of the neutral conductor. It is also important to consider the impact of harmonic currents on the neutral conductor. Harmonic currents are currents that are multiples of the fundamental frequency of the electrical system, which is typically 60 Hz in the United States. Harmonic currents can be generated by a variety of electronic devices, such as computers, fluorescent lights, and variable frequency drives. Harmonic currents can cause the neutral conductor to be overloaded, even if the connected load is within the limits specified in the National Electrical Code. This is because harmonic currents add up in the neutral conductor, even if they are out of phase with each other. To mitigate the impact of harmonic currents, it is important to use equipment that generates minimal harmonic currents. It is also important to size the neutral conductor large enough to carry the harmonic currents. The National Electrical Code provides guidelines for sizing the neutral conductor to carry harmonic currents. These guidelines take into account the type of loads being served and the amount of harmonic current that is expected to be generated. In addition to sizing the neutral conductor properly, it is also important to install the neutral conductor correctly. The neutral conductor should be run in the same raceway as the phase conductors. This will help to minimize the impedance of the neutral conductor and to reduce the voltage drop. The neutral conductor should also be properly terminated at the neutral bus in the panel board. This will ensure a solid electrical connection and prevent overheating of the neutral conductor. Finally, it is important to inspect the neutral conductor regularly to ensure that it is in good condition. The neutral conductor should be checked for signs of damage such as corrosion, overheating, or loose connections. If any damage is found, the neutral conductor should be repaired or replaced immediately. In addition to the above considerations, it is also important to be aware of the potential for ground faults in electrical systems. A ground fault is a fault that occurs when a phase conductor comes into contact with a grounded surface such as a metal enclosure or a water pipe. Ground faults can cause electrical shock, fire, and equipment damage. To protect against ground faults, it is important to install ground fault circuit interrupters or ground fault circuit interrupter breakers on circuits that serve receptacle outlets in wet or damp locations. Ground fault circuit interrupters are devices that detect ground faults and quickly interrupt the flow of electricity. Ground fault circuit interrupters are typically required by the National Electrical Code in bathrooms, kitchens, and other wet or damp locations. In addition to ground fault circuit interrupters, it is also important to ensure that all electrical equipment is properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and to prevent electrical shock. The National Electrical Code specifies the requirements for grounding electrical equipment. These requirements vary depending on the type of equipment and the location where it is installed. It is important to follow the National Electrical Code requirements for grounding electrical equipment to ensure the safety of people and property. Furthermore, we should always be mindful of the color coding conventions for electrical conductors. As mentioned earlier, the neutral conductor should be color-coded white or gray. This makes it easy to identify the neutral conductor and to distinguish it from the phase conductors. The phase conductors are typically color-coded black, red, and blue in a three-phase system. The grounding conductor is typically color-coded green or bare. It is important to follow the color coding conventions when installing electrical wiring to ensure that the wiring is installed correctly and safely. In addition to the color coding conventions, it is also important to be aware of the marking requirements for electrical equipment. Electrical equipment must be marked with the manufacturer's name, the voltage rating, the current rating, and other important information. The markings must be legible and durable. It is important to read the markings on electrical equipment before installing or using the equipment. The markings provide important information about the equipment's capabilities and limitations. It is also important to be aware of the safety precautions that should be taken when working with electrical equipment. Electrical work can be dangerous, and it is important to take precautions to protect yourself from electrical shock, burns, and other injuries. Before starting any electrical work, it is important to disconnect the power to the circuit. This can be done by turning off the circuit breaker or fuse that supplies power to the circuit. It is also important to wear appropriate personal protective equipment, such as rubber gloves, safety glasses, and insulated tools. Rubber gloves will protect you from electrical shock. Safety glasses will protect your eyes from flying debris. Insulated tools will protect you from electrical shock if you accidentally come into contact with a live wire. When working with electrical wiring, it is important to use the proper tools. Wire strippers are used to remove the insulation from wires. Wire crimpers are used to crimp connectors onto wires. Pliers are used to grip and bend wires. Screwdrivers are used to tighten and loosen screws. It is important to use the correct tool for the job to avoid damaging the wiring or the equipment. After completing any electrical work, it is important to test the circuit to ensure that it is working properly. This can be done using a multimeter or a voltage tester. A multimeter is a device that can measure voltage, current, and resistance. A voltage tester is a device that can detect the presence of voltage. If the circuit is not working properly, it is important to troubleshoot the circuit to identify the problem. The problem may be a loose connection, a broken wire, or a faulty component. Once the problem has been identified, it can be corrected and the circuit can be tested again. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. A qualified electrician has the training and experience to safely and properly install and repair electrical wiring and equipment. Hiring a qualified electrician can help to ensure that your electrical system is safe and reliable. In conclusion, understanding the rules and guidelines for sharing neutrals in electrical systems is crucial for ensuring safety and compliance with electrical codes. By following the National Electrical Code requirements, considering practical considerations, and taking appropriate safety precautions, it is possible to design and install electrical systems that utilize shared neutrals effectively and safely. Always remember to consult with a qualified electrician for any electrical work to ensure that it is done properly and safely.